வணக்கம் நண்பர்களே. இன்னைக்கு வீடியோவில் we discuss about then last class continuation then laser. So last class we have to discuss about some of the basics that is then laser. Then before we have to recall some of the point what we discussed in the last classes. Next we move on to the today topic, then stimulated emission. Then we discuss about some of the important MCQ. Okay. So what are all the basics we discussed in the last classes? Then laser. So we know that what is meant by laser. Laser is a then light amplification by stimulated, that is the important, stimulated emission of radiation. Okay, so most important. Then what are the characteristics properties of laser? Then it is highly monochromatic. So that number last class we have to discuss. Okay, we have to just recall monochromatic, and next one is a coherent. The next one is a highly directional. Then that should be a very high intensity. For medical purpose we have to use last one. Okay, for surgery cases. Okay, so these are all the cases we have to discuss last classes. Then what is meant by ordinary light and laser we have to different. Then comparing to the ordinary light, then what all the characteristics behaves as a laser. Then after that we have to discuss about the energy relation. What is the energy relation? There should be a famous one. Then E is equal to then H nu. Okay, so H is, we know that H is the Planck's constant. Planck constant. Then what is the value for H? Then 6.626 into 10 power minus 34 joule second. Okay, so what is the wavelength relation? So then wavelength relation we have to write it as then C is equal to then lambda by VE, then 1 by lambda is equal to, then we have to write like this. Okay, so based upon this we have to do some of the problem in the last classes. Then you know that what is the constant value of C? Then C into 10 power minus 8 meter per second. Okay, so some of the unit conversion we have to discuss last classes. If you want to see the last classes, the link will be given in the description, or you have to preferred or visit the channel playlist. Okay, so now move on to the today topic, that should be stimulated emission. So we know that then how stimulated emission occurred. Well known about that. Then laser nane, then most important, then word stimulated emission, stimulate panano, that is the important. So when an incoming photon then triggered on the excited atom to emit the another photon, so we have to get two identical photons are produced, that is called stimulated emission. Okay, so there are many of the books there should be a given. Okay, this is the excited state, there should be a ground state, excited state. In that excited state there should be a atoms, so we have to give then E is equal to H nu. Then it comes to ground state, it produced identical photon. Okay, two identical photons are produced. So those cases are elaborately given in all books. Okay, then you have to go through it yourself. Okay, so mainly what you know about that, then stimulated emission, when an incoming photon triggered on the excited atom, when it comes to the ground state it emit another photon, so we have to get two identical photons are produced. Okay, so this is the stimulated emission. So then stimulated emission was proposed by then Einstein. Okay, first he started the work on 1916, then proposed 1917 only. Okay, the first ruby laser was proposed by in 1960 by Myman. Okay, these are all the basics. Okay, so the correct option is B, Einstein. Okay, so in stimulated emission, then emitted photons are this is the I already say that there should be a two identical photons are produced. Upon two identical nale, we have to get the emitted photons have same energy, same phases and same direction and same frequency. Upon here different, no need, okay. A random, no. So lower energy, low. So there should be same energy, not only same energy but also then same direction, same phase and same energy. So மேலே இருக்க ஆட்டம் எல்லாமே கிரவுண்ட் ஸ்டேட்டுக்கு வரும்போது then we have to get two identical photons are produced, all are same, okay. We have to remember that, okay. So already we have to discuss about then photons are identical means then we have to get same frequency, okay. So this is the problem. Then we have to give given that energy difference equal to 2 electron volt and what is the frequency, okay. So what is the unit for energy? So energy unit is, that should be a joule. Up here we have to given that electron volt, so then we have to convert into joule. Up then 2 electron volt can be converted into a joule convert pannana, then we have to multiply by 1.6 into 10 power minus 19. So after we have to multiply, then we have to get 3.2 into 10 power minus 19 joule, okay. So in electron volt kuduthiranga, then electron volt convert into joule. While converting into joule we have to multiply 1.6 into 10 power minus 19, okay. Next we have to find out the frequency. So we know the relation, energy relation. So then E is equal to then h nu upon nu is equal to then E by h. About here what is the value for here he? So already we have to find out then 3.2 into 10 power minus 19 joule divided by what is h is the Planck's constant. We have to discuss in the first slide itself. About 6.626 into 10 power minus 34, then we have to divide, then we have to get 4.83 into 10 power 10 power 10 power 14, okay. 10 power 14 hertz. So then we have to simplify, then 4.8 into 10 power 14 hertz, okay. So in many previous year question paper the question may be like this only, then simple one. Then we have to convert the units, okay. So then electron volt la kudutha, then how to convert into a joule, then centimeter la kudutanga, then meter convert pannom, meter la irundhu centimeter, then nanometer la irundhu then we have to convert into a then wavelength. So conversion then it should be easy. Then we know the relation for frequency, then is equal to h nu, then we have to find out from, then we have to get the relation, okay, frequency relation. So after that we have to just apply the given data, then we have to find out the solution, okay. So then laser works based on, so this is the most important, it is work based on stimulated emission, most important, okay. So answer C is correct, okay. So in stimulated emission photons are, what is that, photons are weak irukade, random irukade, incoherent na, no, incoherent for only ordinary light. The stimulated emission photons are coherent, that should be a same phases. So answer B is correct, okay. So answer B is correct, okay. So these are all the questions important from the stimulated emission. So then what are all the point you have to remember? Then incoming photon triggered, then we get emission, while emitted photon we have to get two identical photons are produced. So then coherent radiations are obtained, okay. These are all the point you have to remember while studying stimulated emission, okay. So if you want to join test batches, then you have to download the DPN Academy app from the Google Play Store. The link will be given in the description. Okay, then WhatsApp and everything link will be given in the description. If you want to join, then you have to use those links. Okay, then thank you. The next classes we discuss about the next topic from the laser. Okay, thank you.